what you would need to do is to find where they cross over. And actually, I saw a pretty good illustration of this. This one. Let me bring this in. So the area, the shaded area that we need for this one, you would find the kind of total area minus the other area. And they have, that looks very similar, is it? Yeah, it's very similar. Let's take this one in as well. Yeah, I just want to see, do they all look like, okay. Put that down there. So in this case, we need to find the area, like the total area.
Yep.
Minus the unshaded area underneath, and that will be equal to the shaded area above. And so where would these two cross over? What is that x coordinate? How would you get that?
Would you need to use one of the equations on the right of the graph?
Basically, when they cross over, they both have the same x coordinate and both have the same y coordinate.
Yeah.
And so how could you use that to get where they cross over?
Wait, when you say they both have the same, what are you talking about?
Like, so this straight line is y equals x.
Yep.
The curve is y equals x times 4 minus x.
So could you sub in for y equals x, y equals... Well, no, you can't. You can't do that.
So it would be like y equals y, or x equals x times 4 minus x. So you could do that to solve for the x coordinate.
So can you divide by minus x on both sides?
I'd just expand the brackets and go from there.
So it'd be 4x minus x squared.
Yeah. And then
Equals x.
Mm-hmm.
And then could you minus x on both sides?
Yeah.
So it'd give you 3x equals 0 equals 3x minus x squared.
Yeah.
And then could you solve that as a quadratic?
Yep.
So it'd be minus x squared plus 3x.
Yep.
Minus... I got x is 1 and x is 0.
X equals...
Oh no, sorry, x is 3.
Yeah, it looked like it would be 3.
Yep.
X equals 3 or x equals 0. So there it's 0. There It is 3.
And then could we use the equation on the bottom for subbing 3 for x?
So that would get you the y coordinate. What we want is the total area. And to do that, you would integrate under that curve from 3 to 0.
So we'd use the equation y equals x brackets 4 minus x.
Yeah, you would do the integral.
And there'll be 3 on the top, 0 at the bottom.
Yeah, and I'll use the way you wrote it as 4x minus x squared.
Okay. And then we sub in 3 for x.
Integrate first.
Oh yeah. So it'd be 2x. Minus 3x. Would it be 3x cubed? Wait, that would be a third cubed.
A third x
Third
cubed,
x.
and this will be 2x squared.
Yeah.
So this is 2x squared minus a third x cubed. between 3 and 0.
And then you sub in 3. And that should be your answer because 0 just gives you 0.
Yep.
So 2. I got 9 as the answer.
Okay. And so the total area is 9.
Yeah.
We want just the shaded area. How would you do that?
So now what you do, y equals x.
Yeah.
So you do it would just give you 3. If y equals
that's the y coordinate.
Yeah, but if y is 3, then x is 3 because they're equal to each other.
That's the y coordinate.
Oh.
We want the area.
So do we need to use integration again?
Yep.
So do we do 3 on the top and 0 at the bottom again? And then y equals x.
Yeah. 3, 0, and that's x.
And then we integrate x.
Yep.
And that would give you a half, right?
Yep.
A half x squared.
Yeah.
And then you sub in 3.
Yep.
So, half. Which is 9 over 2 or 4.5.
Okay. And so how do we get the shaded area?
Do you do 9 minus 4.5?
Yep.
Which is 4.5.
4.5, and that's square units because it's an area.
Yep.
9 over 2, 4.5. Great. And that's and what they noticed is that this one makes a triangle, and so this one they just did a half times base times height, but your way is the more general way. And in fact, let me make this a bit easier. Put that there. So essentially what you did was the integral between 3 and 0 of 4x minus x squared with respect to x, and then you did take away the integral between 3 and 0 of x with respect to x.
Yep.
And because of that, you can bring the two together.
Yep.
And you can say that's the integral between 3 and 0 of 4x minus x squared minus x with respect to x. And you can do 4x minus x. And so 3x minus x squared with respect to x. That should work because it's the same limits.
Yeah.
So let me just check this one. So this one is, instead of 4x, so we only have to integrate once, makes it easier. Between 0 and 3. Yep. And so that makes our lives easier. So we can just simplify, we can bring the two together, so we only have to integrate once.
Yep.
Okay, let's try. So that was, the curve was over the line. This one, the line is over the curve. How do we do this?
Okay. So it wants the shaded region, right?
Mm-hmm.
Okay. So to work out the integrals, do you need the y coordinate as well?
No, because it's
Okay.
a formula with respect to x only.
Okay.
So it's kind of a red herring with the y.
Can integrals be negative?
Why?
Or
What
are they
did
always positive?
you get?
Well, no, I didn't get the answer yet. I did one of the integrals, and I got -8/3.
That's fine,
Okay.
I think. How? Maybe better. So how did you get -8/3?
What I did was first was solve y equals x brackets x -3. So I multiplied out the bracket, which gave me 0. Well, I got it as a quadratic, so I got it as 0 equals x squared minus 4x.
I think it should be -5x, should it? X squared minus 3x minus 2x. So that's x squared minus 3x.
How come it's 2x on the other side? Oh, you need to make. Okay, that's why I went wrong then.
Okay.
Okay. X squared minus 3x. And then you minus 2x on both sides, which gives you x squared minus 5x equals 0. And then you put that into the calculator. Which gives you x equals 5 and x equals 0.
Mm-hmm.
And then you do 5, 0 as an integral. And then you use x squared minus 5x, then you integrate it, which gives you a third x cubed minus 5/2 x squared.
Yeah, slow down. Let's see. So you would integrate. What is the coordinates? So it's basically this triangle.
Yep.
Take away this bit here.
Yep.
The unshaded bit. So how would you get the area for the triangle?
You'd use y equals 2x.
Yeah. So that's going to be the integral.
The integral would be would it just be x squared? Yeah.
It'd be x squared between what and what?
What do you mean between what and what?
So like between what two limits?
Oh, it'd be between 5 and 0.
Yeah, so that's between 5 and 0. And you have to subtract from that What?
It'll be 25 for the bottom left.
Yeah.
Subtract from the integral of x squared minus 5x. And then you sub in 5, right?
So the integral of x squared minus 3x.
Yeah, x squared minus 5x.
3x.
How come?
So it's that one there. That's the curve.
But I thought we to make it 0 on the left, top left, near the top left.
That's just to find the x coordinate of where they cross over.
Okay then. And then you sub in 5 for x, right?
Well, let's see. It's between 5 and a.
Okay.
Because it's just that white bit. So actually this one has to be done there.
So do we sub in a after we've integrated it with 5?
Well, how do you get a? Where are the coordinates of a?
Well, it's a quadratic, isn't it?
So yeah, this curve.
We know one of them 0.
Yeah, this one is 0.
Wait, would it be 3?
Yeah, it would be 3.
Yeah. And then we sub in 5 for x. We haven't integrated it yet.
Yeah, after you integrate.
So you'd get the half x, no, a third x cubed.
Mm-hmm.
Minus 3 over 2x squared.
Yeah.
And then you sub in 5 for x.
Mm-hmm.
Okay. I got 25 over 6.
Okay.
And then you take that away from subbing 3 into x.
Yeah.
Okay. And I got minus 9 over 2 for the second number.
Okay.
And then you put all of that into the calculator.
Yeah.
So it'd be 25 minus. How come there's a 25 at the start?
Because that's the total area.
Oh, okay.
You can do them in parts if you want. The unshaded area is 25 over 6 minus 9 over 2.
I got 49 over 3.
As the final answer, is it?
Yeah.
Over 3. And that's, well, that's exactly 16 and a third, I think. Square units.
Yeah.
Let's say 26 over 49 over 3. Yep, that's it. Tricky. Okay. I think you're alright. Yeah, just find where these cross over. Yeah, fine.
Yep.
Okay. Find the coordinates of A and B.
Okay. Well, can you put y equals the top equation as a quadratic?
Yeah, how'd you do that?
Are you able to put fractions into quadratics?
Yep, I'll send you the calculator.
Okay. I got x is 8 and x is 1.
And what did you put into the quadratic thing?
I put -1 and then fraction 2, and it gave me minus 0.5.
Yeah, so it was like -1/2, 9/2, and -4 equals 0.
Yeah.
What you got were these two.
Okay.
When y is 0. How do we get these two?
Do we need the other equation?
Yep.
Okay. So we can put... Okay, so the other equation. Do we want y on the right-hand side of the equation?
Makes a difference. They made a mistake. That should be equals y.
Okay. Oh, we can solve as a simultaneous equation.
Yep.
So we can minus y on both sides, which gives you x plus 3y minus 13 equals 0, and then we can add 13 to both sides. X plus 3y equals 0. 13, sorry.
Yeah, sorry, there one was correct, sorry. So x... did you do y equals... What was it, sorry?
For what?
What was the one you just got?
X plus 3y equals 13.
Well, x plus 2y equals 13.
But it's equal to y, so you have to minus y on both sides.
Sorry, my mistake. It's not equal to y. My mistake, sorry.
Oh, okay. So it's 2y equals 13.
So 2y equals 13 minus x.
Yeah, okay. So, and then you divide by 2.
Yeah.
So it'd be y equals 13 over 2 minus x over 2.
Yep.
And we can't solve that as a quadratic, can we?
Now...
Oh, wait. Can you?
Now it would be simultaneous. So you want when these two are equal to each other.
On which two?
So the points A and B are when the curve is equal to the line.
Oh. So would you make 13 over 2 minus a half x equal minus a half x squared plus 9 over 2x minus 4?
Yeah.
Okay. And then we want to make it equal to is 0, right?
Yep.
So we can minus 13 over 2 on both sides.
Mm-hmm.
Okay. Which would give you minus 21 over 2.
Okay.
Okay. And you 9 over 2 minus a half, which gives you minus a half x squared plus 4x minus 21 over 2 equals 0.
I believe you'd have to plus a half to both sides. Plus a half.
Oh,
x.
yeah, sorry. which gives you 5.
Mm-hmm.
And then you can solve as a quadratic.
Yep.
Which gives you x is 7, x is 3.
Okay.
So a is 3 and b is 7.
Yeah. And they wanted coordinates, so we better give full coordinate. Better give y coordinate as well.
So we need to, for 3, we need to sub in 3 for y equals a half x squared.
Yeah, I would use the easier of the two, and
Okay.
we rewrote that here as y equals. Is that probably the easiest one?
Okay. So for a, I got 5, y is 5.
And the other one?
The other one is, for b, it's 3.
That's good. Okay, part B.
Okay. So for this, would you do 7 and 3 as an integral?
Yeah.
And what equation would you use though? There's 2.
You want total area minus unshaded. So what one would give you the total area?
Would be the top one, wouldn't it?
Yeah. So it's the integral of the quadratic curve.
Mm-hmm. Is that already integrated, or do you need to integrate it?
We would need to integrate it, but hold your horses.
Okay.
So it's the integral of that one.
Yep.
And then we would subtract the integral between 7 and 3.
And x plus 2, well, not 2y, it'll be 13 over 2 minus a half x.
Yeah, minus a half x with respect to x. But we could bring the two together. And then we won't have to do one integration. And in fact, we already did bring them together. Didn't we?
Oh, so we can use minus a half x squared plus 5x minus 21 over 2.
I believe so.
Okay.
Plus 5x minus 21 over 2 with respect to x, yeah.
So I got, for the integral for 7, I got 98 over 9.
Alright.
And then and then for the second one I got minus 12. So would it be 98 over 9 minus 12?
Yep.
Okay. I got 206 over 9.
I don't like it. So what was the integral?
For which one?
Like in general? Did you integrate it? So
Oh yeah, I did integrate it. I got minus 1 over 9 x cubed for the first part.
minus 1 over 6.
Oh, that's where I went wrong then, probably.
Okay. What was second bit?
5 over 2x squared.
Yeah.
And then minus 21 over 2x.
Yeah. And then what do you sub in?
You sub in 7 first for
What do you sub in second?
3, and then you take away the answer for 7 from the answer of 3.
Yeah.
Oh no, the answer of 3 from the answer of 7.
Yeah. And you get 16 over 3. I just kind of use the old calculator. You would just show you're working out by subbing in, like replacing x with a 7.
Yeah.
Replace x with a subtract, replace x with a 3, and then you can just use your calculator instead of having to put all that into the calculator, and it just makes life a bit easier. Okay, in general they're all going to be the same. Find where they cross over using simultaneous equations, and then you would integrate. I don't think we can do it if you want, but they're going to be the same. Is it worth doing?
Probably not. I think I know how to do it.
So it just takes a bit of practice. I mean, it's just the fractions and stuff. The idea.
Yeah.
Yeah. Coordinates. Yeah. Let's see. Man, why do you have to do me like this? This involves a negative area. I don't like the look of that. So this looks more like it. I'm not going to mess around with negative area. This one, yeah. Let me just see. So this one we did the integral. Let me think. It'll all work out in the end. Yep. And so what do you give yourself for these ones?
Probably between a tick and a half.
I think you're alright. You get the idea. Find where they cross over and then go from there.
Yeah.
Okay, that's chapter 13. This one, exponential functions.
Isn't this the last chapter of pure?
Yep.
Yeah.
Let's see. Exponential functions. Virus grows exponentially. This is what they use for modeling pandemics and what have you.
Okay.
Let's see. I suppose I should. All right. So the y equals 2 to the x. 2 cubed is 8. 2 squared is 4. 2 to the power of 1 is 1. 2 to the power of 0 is 1. Sorry, 2 to the power of 1 is 2. And it keeps halving.
Okay.
It's halving to the left, doubling to the right.
Yeah.
So it gets close to 0 but never reaches it as x becomes negative.
Oh, right, yeah.
And the other way is doubling. So it's going to go like that. What will these graphs look like? Let us see. So we saw y equals 2 to the x. We saw y equals 2 to the x. Put it there. Okay. Y equals 2 to the x.
Yeah.
Y equals 3 to the x. Y equals 1.5 to the x. So I'm just going to write, that's the 1.5 one. That's the 2. That's the 3. A half to the x. 1 over 2 is the same as 2 to the power of what?
2.
Any idea about
So would it be 2 to the power of 2 brackets and then whatever x is?
that? Just in general, a half is the same as 2 to the power of what? So that's like 1 over 2 to the 1. That's same as 2 to the power of minus 1.
Oh yeah, I remember now.
And so a half to the power of x is the same as 2 to the minus 1 to the power of x.
Yeah.
Power times power. And so that's the same as that.
Okay.
Spot the difference between y equals 2 to the x and y equals 2 to the minus x.
What? They'll give you a negative number. Wait.
The x's have swapped, and so it'll be a reflection in the x direction. Like
yeah.
Oh, it's 2 to minus x. And yeah, so that's a reflection. And the other one, 1.5, took longer. 2, 3.
Yeah.
Okay, sketch this graph. Given the coordinates and stuff. Okay, any idea how you'd sketch this one?
Okay. So it would be x to the minus 1, brackets x to the power of x minus 3.
So like 2 to the minus 1, x minus 3. Like that.
How come it's 2? Oh, because the bottom's 2, isn't it?
Yeah.
And then would you multiply 1 by everything on the outside? Minus 1, sorry.
Yep.
So it'd be minus x plus 3.
Yep. Or 3 minus x. Yeah, let's go with minus x plus c. But yeah, 2 to the minus x plus 3. This is getting weird. All right. So let's see. Y equals 2 to the x looks like that.
Yeah.
What will y equals 2 to the minus x look like?
The other way around.
Yep. And then what will y equals 2 to the minus x plus 3 look like?
So would that mean it's 3 higher on the y-axis?
It's next to the x, so it affects the x direction.
So is the curve, when it curves, is it further away from the y-axis?
I think it will move a 3 to the left.
Yeah.
And so, yeah, it's like that or something.
Yeah.
I think so.
Yeah.
Give the coordinates of the point where the graph crosses the y-axis. When it crosses the y-axis, x is 0.
Yeah.
I shall make x 0. What do you get? And just to be safe, I'll go back to the... I'll use R1. So 2 to the minus x plus 3. Where it crosses the y-axis, x is 0.
So it'd be 2 to the 3.
Yep.
Which would give you a 8.
Yep. So that crossover 8. And if I use their one, the original one,
yeah,
that was a half to the power of 0 minus 3, and you get 8 as well.
Yeah.
Great. Let's see. And Did they want us to do it from somewhere?
I think the curve moved more to the right because it's positive 3 when you add it. On the answer, it says it's not to the left, it's more to the right.
But they have -3. They have minus... Oh, I wrote it wrong. No, did I? 2 to the -1. That should be plus... If... 3 to the right.
It did, didn't it? It moved 3 to the right.
It did. Alright. That's a thinker. So I should have gone 3 to the right. Alright. Wait. No, not like that or something. Okay.
Yeah.
Okay, we have to sketch this one.
Okay.
Yeah. How would you do A?
Okay. Be 2 to the minus x.
Yep. So what will that look like?
And then do we sub in for x certain numbers, like say -3 to +3?
What does y equals 2 to the x look like?
Is it three like above 0 on the x-axis, on the y-axis?
So in general it looks like that.
Okay.
And so y equals 2 to the minus x.
It's the other way around.
Yeah. And it says labeling any points of intersection and giving the equation of any asymptotes. So where does it intersect with the... What's the y-intercept?
2.
Nope. You can use calculator if you want. On the y-axis, x is 0. Can you hear me okay?